What if I told you there's a new theory out there, one that claims to build all of physics, everything we see, from a single logical idea? It's called the theory of expanding matter. And let me tell you, it's not just about tweaking a few equations. No, this theory wants us to rethink everything we thought we knew about existence itself. Welcome to the age of expansion.
So it all starts with maybe the biggest question you can even ask. You know the one. Why is there something instead of nothing? But here's the twist. This theory doesn't try to answer it by looking at stars and galaxies and working its way back. Nope. It starts from the other end. It begins in a state of perfect, absolute nothingness, and then tries to logically prove why a universe like ours had to happen.
All right, Section 1, the existential necessity. So let's get into it. How do you actually build a universe from, well, nothing? The whole idea kicks off in a state of absolute perfect symmetry. I mean, imagine a place where you can't tell any one point apart from another. It's like a perfectly blank canvas with nothing on it all.
Okay, so the first step in the logic is actually pretty straightforward. For anything to exist, to be something, it has to be distinct, right? It has to be different from not being. Existence itself needs some kind of difference, a fundamental distinction to crack that perfect symmetry. If you don't have that, well, you're stuck in nothingness forever.
But, just making a distinction isn't going to cut it. Think about it. If that difference was just a quick flash, a little blip that appeared and then vanished, you'd be right back to square one. So for existence to actually stick, the relationship that was created by that very first distinction, it has to be preserved somehow.
So here's the million-dollar question. How do you keep that relationship going in a totally self-contained system? I mean, there's no outside ruler to measure things against, right? The theory makes this really cool point that other transformations, like, say, rotation or just moving something, they already assume there's some kind of background space to measure against. But what if there isn't? The argument is that the only thing you can do, the only transformation that can both create and preserve distinction from the inside out, is expansion. So get this, expansion isn't just something the universe happens to be doing. According to this theory, it's the only thing it could possibly do to exist in the first place. Wow.
Okay, that brings us to Section 2, the rules of the game. So, if the universe must expand just to exist, it can't just be some chaotic, random explosion, right? It has to follow a very specific set of rules, all based on that one core principle, preserving the relationships between things.
So what kind of rule book are we talking about? Well, the theory says the universe has to operate in a very specific kind of mathematical space. It's called real projective three-space. Now, why that? It's actually pretty elegant. In a universe that has no outside, you can't have an external ruler, so absolute size is meaningless. The only thing that matters, the only thing that can have any real meaning, are the ratios and proportions between things. And that, my friends, is exactly what projective geometry is all about.
And this special type of geometry has one unbreakable law. As everything grows and expands and transforms, there's this one special measurement, the volumetric cross ratio, or VCR, that absolutely must stay the same. It has to remain invariant. This VCR, you could say, is the fundamental law that makes sure all those relationships are perfectly preserved. It's like the universe's ultimate contract with itself, ensuring existence doesn't just fall apart.
All right, let's move on to the third part, the code of reality. And I gotta tell you, this is where things get really, really wild. Because when you take that one single rule, that the VCR has to stay constant, and you apply it to an expanding system, something incredible happens. It turns out the system can't just create any old structure it wants. Not at all.
The math just spits out this result. For any structure to be stable, for it to stick around as the universe expands, it can only exist in, get this, exactly 14 different configurations. These numbers aren't just picked out of a hat. They are the only mathematical solutions that work with the geometry. Think of them as the only stable notes the universe is allowed to play on its instrument.
And here's the real kicker. These aren't just abstract mathematical curiosities. No way. They seem to map one-to-one with the fundamental building blocks of our universe. The number 5, that corresponds to how quarks are confined. The number 12, that's related to electron fields. 55, photons. It's like they stumbled upon a kind of periodic table for reality itself, where every stable piece of our universe is predicted by pure logical geometry.
And if that wasn't mind-blowing enough, get this.
The people behind this theory found that this exact same set of numbers popped up in a completely different area of math they were studying, something to do with the famous Fibonacci sequence and another one called the Pell numbers. So you've got two totally different paths, one from the geometry of existence and one from pure number theory, and they both lead to the exact same secret code of the universe. That's just uncanny.
Okay, I mean, this is all fascinating stuff, but a pretty story isn't enough to make a theory of physics, right? It has to actually connect with reality. So, can this code, this whole system built from pure logic, can it actually predict the real numbers, the constants we measure in our labs?
Well, let's watch this thing in action with a really key calculation. You start with the biggest final stable number in the code, 408. That represents the closure point of the whole system. Then, you divide it by the 3 spatial dimensions we live in. 408 divided by 3 is 136. And for the last step, you add 1, which is like resetting the system back to its original unified state, before that first distinction was ever made.
So 136 plus 1 gives you 137. And what's so special about 137? Well, it just happens to be the integer part of the fine structure constant. This is one of the deepest, most mysterious numbers in all of physics. And the really astounding thing here is that this number wasn't measured. It wasn't an input. It was derived from scratch, using nothing but the internal logic of the theory. That's a pretty big deal.
So now we're at section 4, a new map of physics. Because if you can derive constants like that, you're not just adding a footnote to physics, you're claiming you can redraw the entire map and explain some of the biggest mysteries out there in a whole new way.
Let's start with gravity. We usually think of it as this mysterious force that pulls things together. But in this theory, it's something else entirely. Imagine matter, like a planet, is a spot that's just expanding a little bit slower than the space around it. The space further out is expanding faster, so it creates this kind of inward flow, pushing everything towards the slower region. What we feel as the pull of gravity is actually the push of expanding space.
What about the speed of light, c, the ultimate speed limit? Why that specific speed? Well, in this model, it stops being some random number and becomes something you can actually wrap your head around. C is the baseline rate of expansion. It's the speed that reality itself is literally unfolding. It makes perfect sense that you can't move through space faster than space itself is being created. It's the speed of now happening.
And then there's quantum entanglement, Einstein's spooky action at a distance. This theory has a beautifully simple way of looking at it. Think about drawing 2 little dots on a balloon. As you blow up the balloon, the dots get farther and farther apart, right? But they are still fundamentally connected by the same piece of rubber. The idea here is that entangled particles were never truly separate to begin with. The distance between them is just an illusion created by the ongoing expansion of space.
There's this fantastic quote from the physicist Oscar Prill that just sums it all up perfectly. He drew islands, the universe is a balloon, the paradox ends the moment you stop pretending things were ever apart. What he's saying is that maybe all these paradoxes in physics aren't real problems with the universe. Maybe they're just problems with our maps, with our assumptions that things are separate, when they're actually all part of one connected, expanding whole.
Okay, so for our final section, a falsifiable universe. Look, a theory can be beautiful, it can be elegant, it can explain everything. But if it's not science, what's the point? And to be science, a theory has to be vulnerable. It has to stick its neck out and make predictions that could actually be proven wrong. If it can't be falsified, it's not science.
And this theory absolutely does that. It doesn't mess around. It makes very specific, testable predictions. For one, it says we should find 3 new types of particles at very precise energy levels, 2.2, 3.6, and 5.8 GeV. Our standard model doesn't predict those. It also predicts a whole new kind of phase transition at a crazy high energy level, around 129 TeV. They call it the silver transition. And even better, it tells us exactly how to kill it. If someone finds a stable particle that doesn't fit into their code of 14, the theory's done. If someone proves you can have existence without expansion, it's over. This theory isn't just asking for a debate, it's practically begging for a fight.
So, at the end of the day, what are we left with? The theory of expanding matter offers this incredible start-to-finish story, from the pure logic of why anything should exist, all the way to the concrete numbers we measure in our labs. It's asking us to consider a universe that isn't just a random collection of laws and constants, but is instead an elegant, logical structure that had to unfold this way from one simple starting point. Which leaves us with the big question, is this the true map of reality, or is it just a beautiful illusion?